Boa tarde, bem-vindos à última plenária que assinala o encerramento do Encontro Ciência 2022. Cancro, avanços e desafios é o tema desta sessão, para a qual recebemos em palco Rebecca Fitzgerald, professora em Prevenção do Cancro na Universidade de Cambridge e diretora do Centro de Investigação do Cancro do Reino Unido, o Instituto de Detecção Precoce, que se junta a nós por videoconferência. Shireen Hassan Abbas, diretor executivo da Farco, e João Barata, investigador e coordenador do Laboratório de Sinalização em Cancro do Instituto de Medicina Molecular João Lomba Antunes. Para moderar o debate, a presidente da Fundação para a Ciência e Tecnologia, Helena Pereira.
So, good afternoon. It is a pleasure to be here moderating this last session of our Ciencia 2022. And it is, in fact, a session with a very, very important topic. You know that we devoted these 3 days on speaking and discussing topics related to the missions that Europe is pursuing. And one of the most important missions, well, they all are important, but one that the public perceives as very, very important is the mission related to cancer. And so this session is on that. We have 3 speakers working in different areas, but all devoted to this topic, and it is our pleasure to hear from them. The first one will be Rebecca Fitzgerald. She is not here, she is on the screen. Hello, Rebecca, how are you? Hello. Rebecca is a professor at University of Cambridge, and she is working on the early detection of cancer, and I'm sure she will tell us about her successes on that. So, Rebecca, the screen is yours. Yes, Rebecca, please do.
Great. So, thank you very much for speaking about screening to improve cancer outcomes, the challenges and opportunities. And what I'm going to do is start with a brief overview about why this topic is so important. Then to talk a little bit about the work that I've been involved with for the European Commission to review the evidence for screening. And thirdly, to talk about my own work in cancer of the esophagus in particular. So these are my disclosures. In the last part of the talk, I'll be talking about the technology cytosine which I've developed. So what's the rationale for the early detection of cancer? When we look at the 10 years In normal young tissues, we have very few mutations. In aging healthy tissues, they start to accumulate, but at that point, there's still no consequence to the individual. Some of the mutations can be quite similar, actually, to those we find in cancer in normal healthy aging tissues. But in cancer tissues, the clones start to expand and accumulate further abnormalities and genetic instability, and that will lead to an invasive consequential cancer. And that's what we want to avoid. So I think these graphs perhaps highlight the positive impact of screening, but also the challenge of overdiagnosis. This is from a really excellent piece of work published in the New England Journal a couple of years ago, and it goes across many different cancer types, but I just highlighted here thyroid and cervix. So there was a move towards trying to really identify early lesions in the thyroid in some parts of Asia, and this led to a massive increase in the detection of thyroid, so you can see an increase in the incidence in the blue line. But if you look at the mortality, then that actually wasn't impacted. So we were finding more cancers through the screening, but not actually reducing mortality. So that suggests overdiagnosis. On the other hand, cervical cancer has been a massive success story for screening. And we have not only reduced metastatic disease, but also the mortality from cervical cancer. So this is what we want to do. We want to reduce mortality through our screening. And this is a very important outcome. So there's been a lot of discussion in recent years about how we really can do our screening most effectively, how we can identify the individuals at risk and really focus our efforts on those risk groups. In the NHS, in the UK, and in the US, with the US Preventative Services Task Force, there has been a discussion about how we adapt our current population-based screening programs to be more risk-based. And this is a strategic priority for the NHS.
Thank you so much, Rebecca, for this beautiful presentation and talking about the screening and this concept of precision screening, which was so valuable. But we also focused something that we have discussed a lot during this meeting here, is about the need to have a knowledge-based and evidence-based information in order to take decisions, and how one can use these high-level expert groups and expert workshops to make this summing up of evidence and of designing protocols and ways of advancing in a smart and knowledge-based way. Thank you so much, Rebecca. It was very, very much interesting. We will continue now with a slightly different aspect. Dr. Abbas will speak us about the use of pharmaceuticals, of drugs, of compounds that can be used globally at convenient cost to help combat cancer. Please, Dr. Abbas.
Bismillah ar-Rahman ar-Rahim. Ladies and gentlemen, it's really an honor to be here with you now. And as you said, it's 15 minutes or less, so let's start saving lives, because every 80 seconds, one person dies from hepatitis C. With COVID-19, the first year, 2 million people passed away, yet with hepatitis B and C, 1.5 million people passed this year. But with COVID, they died in 10 days. With hepatitis, they died in 10 years, yet annually 1.5 million. So how can we save patients and how can we deal with patents? Because I attended the United Nations Secretary General High-Level Panel for Access to Medicine. I was the speaker number 99 out of 100 speakers, and they were each pulling at the side, patients, patent office, WTO, WIPO, multinationals. So I said, to P or not to P, that's the question. To patent or not to patent, that's the question. Rights to life versus trade gains. And we came with a formula that we have to work in parallel. Let the multinationals spend millions and millions and millions, and let some governments work together. And this is what we did with the Malaysian government and Thailand, together with DNDi and Médecins Sans Frontières and Medicines Patent Pool. And we made the first drug master file and the first new drug application for curing hepatitis C. Every year we have this. In the past 8 years, 8 million people were cured worldwide from hepatitis. And the medicine is only for 3 months with complete cure. It's a complete cure. But 8 million, 4.1 million of which were from Egypt, 3.9 million were from the rest of the world. How did we do that and how can we make it? We see here that also the Sustainable Development Goals, the WHO would like to screen 90% of patients with hepatitis B and C by the year 2030 and to cure 80% of which, so this means we have to cure for the coming 9 years 7 million patients every year. Awareness, affordability, and accessibility. My company is a young company, although we produce 750 million pharmaceutical packs per annum. So every morning I produce 2.5 million packs with 8,000 employees, but the average cost per pack is €1. So all of us know about the 4 Ds: doctors, drugs, diagnostics, and norms. We convey them into 12 Ds, starting with direction and political will. When President Sisi, President of Egypt, he said, I have a dream, I'd like to eliminate hepatitis from Egypt. Then discoveries, documentation, demand fulfillment, diplomats, detailing, data management, norms, doctors, drugs, diagnostics, and so on. As we said, we started by curing all waiting lists, yet there were many people undiagnosed. So we got mobile clinics, and President Sisi started his order to Ministry of Health to make something called 100 million lives, in which 60 million Egyptians were analyzed and diagnosed, and those who were found were treated in a couple of years. Discoveries. The medicine for hepatitis C was not patented as is, but the API itself, the raw material, the process of making it and the polymorph shape was having a patent. So we had to make a new non-proprietary process, non-infringement process, and to register it. Also, we acquired a company in the States that made R&D for a new product, and we worked to make it and to get it into reality, and also diagnostics. The price per kilogram was $1 million. We built a factory, and we made 10 kilograms for $1 million, 100 kilograms for $1 million, a ton for $1 million, so we are 1 per 1,000 competitive. So when the drug for the world was for $100,000 per person, we produced it for less than $100. As we said, we work with the NDI, and I have a speech on the 25th of May in Davos, how to make fundraising for eliminating hepatitis worldwide to go with the SDGs in making 2030 a world free from hepatitis C. Diagnostics. I call this TNW, the magic wand, and now we will call it not again. Because 2 years and a half ago, if I told you I can lock Europe, I can lock the States, nobody could have believed me. But do we need new pathogens to come and make the same after a few months or few years? How can we find a non-invasive, no quarantine time needed for detection, less than 1 minute, and you can upload new genotypes and you can add up to 12 genotypes, including HCV, HIV, HBV, COVID-19, and H. pylori. Many people have H. pylori, but not much of them would like to make the stool analysis or the FIT test. So just moving with a handheld screening device, which I think this will be the first project that we work together, Egypt and Portugal, in transferring ideas and, as you said, evidence-based science. We need evidence. So if we have 100 people, 10 of which are having HCV, in less than 2 minutes, we can get the 10 aside and the 90 aside. Then documentation. When we made the new medicine for hepatitis C, some people can say it's not high quality. So we had 4 WHO pre-qualification for the API plant, for the finished dosage plant, for the bioequivalence center, and the dossier was 12,095 pages. Demand fulfillment with Médecins Sans Frontières, with the ERP, we were a good supplier, and we looked for diplomats like Daniel Alves, Leo Messi, Ronaldinho, Roberto Carlos, and others. And they really helped us a lot in advertising and reaching patients.
In the past 2 years, a lot has happened. Leo lost some finals and won some more. He scored 102 goals with his team's help. He had Matteo, his second son, went around the world in just 64 days for a cause. Got a bunch of titles, got injured, treated, and healed. And in the meantime, Melanie has been waiting. Just like 100 million people forced to wait over 2 years to start their cure from hepatitis C.
Todo lo que he conseguido en estos últimos 2 años no significa nada si entre todos no podemos cambiar la vida de Melanie y de mucho más como ella. Nadie debería esperar por un tratamiento.
Start your treatment now at torrentcure.com.
So if the treatment could cost $100,000, if you come to Egypt, it will cost $100 plus aeroplane tickets and a couple of days in the hotel. We also used Daniel Alves not only as a diplomat, but to talk to people in South America.
Boliviano não tem preço, razão pela qual ele decidiu destinar tratamento contra a hepatite C, em oferta gratuita ao povo boliviano. Em Bolívia, cerca de 600 pessoas vivem com hepatite C. En la mayoría de los casos, son personas con escasos recursos económicos y son ellas las que se beneficiarán de la ayuda humanitaria que llegará a través del Programa Nacional ITS, o VIH, SIDA, hepatites virais do Ministério da Saúde. Se salvo vida, serei muito mais feliz do que sou agora.
We also made advertisement in Egypt, and as we said, doctors, dorms, data management was very important to collect data from 60 million people. This is Roberto Carlos with the team, drugs, diagnostics, and dorms. And here we say we have put forward a proposal to out-license large territory for medicines patent pool and DNDi, and we started registering our new drug application in China, in South America, and other countries. So we say rich and poor are alike on the promise of leaving no one behind. Action speaks louder than words. Here at the Trilateral Symposium, WHO, with the attendance of WHO Director General, WTO Director General, WIPO Director General, and Dr. Adhanom, he said, Shukran Jazilan Misr. Thanks a lot, Egypt, for what you did. And he came September 29 to meet President Sisi and to see the Egyptian experience, which we can transfer via Minister of Health and Higher Education to our brothers and sisters in Portugal. We say action. Jump into the middle of things, get your hands dirty, fall flat on your face, and then reach for the stars. By working together today, we can make a better tomorrow for all humankind. What we can do with Portugal? First, share the elimination experience, the ecosystem, the 12 Ds. Second, pathogen screening device, testing and registration, and this could be done with Ministry of Health. Third, clinical trial for anti-cancer, Egyptian herb that we made a patent in the USA, and together with your science and our product, we can make something good for humankind. This is an immunotherapy, single herb, no side effects, and as Elena said, evidence-based medicine. This was a poster made in Italy in one of the oncology conventions. And let me say in 2 minutes, lessons learned from A to Z. A, affordability makes access. Believe in the cause. Create the rules of the game. Direction and political will is the clue. Ecosystem formation. Funding till snowball rolls. Governments to support research. Harmony between team members. Infection control. This device not only detects in patients, but also in objects. So if I go to renal, what do you call the machine for renal dialysis, yes? You can detect if someone with HIV or HCV used this and contaminated the machine for cleanliness. Join the right people together, knowledge transfer, logistics and economies of scale. As I said, we started with the kilogram for $1 million and we reached less than $1,000. Media for education and motivation, NGOs partnership, organic growth, proper planning prevents poor performance, quality safe affordable medicines, R&D is the way out, strategic fit, tour and cure is an alternative, United Nations umbrella, values, love, trust, and just. Will comes first, expatriates collaboration, yield analysis and data management, zigzag pathway, go under, go through, but never give up. The most successful people are those who are good at plan B. That's the last slide, the essence of today. I expect to pass through this world but once. Any good I can do, or any kindness that I can show, let me do now, for I shall not pass this way again. Thank you very much.
Thank you so much for your presentation. This is really a challenging and full of hope presentation. And you talked not only about the knowledge behind, but also the need to contact society and people and to disseminate the results and the message. This was really a clear lesson to all of us that it's not just doing research and finding new things, it's also to communicate our results to society and interact with the different people. So thank you so much. We are now having João Barata. He is a professor at the Faculty of Medicine of the University of Lisbon and a researcher in one of our research centers, EMEM. João, please.
Thank you so much. So it's a great privilege to be here in this very interesting forum. And of course, after the very inspiring talks that preceded mine, I have tough business ahead. In any case, I'll be trying to follow up on the topic that is the one that gathered us here for this last session, cancer, its successes and challenges, and have my own perspective on the topic and a bit of our humble contribution to it. So if we want to beat cancer, it's obvious that we have to try at least 3 different things to have better prevention, as we have already very elegantly heard in the first talk, and effective early diagnosis as well, and we need to have better treatments. And I would argue that for any of these 3, but particularly for the last one, we need to have a better understanding of the biology, of the underlying biology of cancer, actually the underlying biology in general. Let me give you a couple of very fine examples of what I mean in the next slides. We all know that the Nobel Prize for Medicine in 2018 was given to James Allison and Tasuku Honjo for their discovery of cancer therapy by inhibition of negative immune regulation. Now, both Allison and Tasuku Honjo were basically immunologists, researchers that did for a long time that dwelled on the mechanisms that underlie immune responses to in a number of different scenarios, and that found out the importance of CTLA-4 in the case of Allison and PD-1 in the case of Honjo. And of course, CTLA-4 and PD-1, now called immune checkpoints, are essential for the homeostasis of the immune system, in the sense that they are expressed when we have an immune response, but we don't have an exacerbated immune response, so we don't have autoimmunity to ensue, for instance. And by exploring the mechanisms, the underlying mechanisms and the underlying biology associated with these 2 molecules, both of these illustrious researchers ended up realizing that by inhibiting these immune checkpoints, we could have a very powerful mechanism to trigger an immune response against cancer. And that's why they ended up winning the Nobel Prize. Another example of how understanding the biology, the mechanisms of disease may lead to not only obviously better knowledge, but to effective treatments is exemplified by chronic myeloid leukemia. This story also illustrates how long it can take from the first knowledge generated in a certain disease until that translates into effective new therapies. Now, in the case of chronic myeloid leukemia, Noel and Hungerford in Philadelphia in the 60s identified this minute chromosome 22 that's considerably smaller than the already small chromosome 22 that basically identified all patients with chronic myeloid leukemia. It took 13 years until Janet Rowley, also in the United States, to show that the chromosome, the Philadelphia chromosome, so the chromosome 20, the small chromosome 22, actually resulted from this reciprocal translocation between chromosome 9 and chromosome 22. And this translocation originates a fusion protein, BCR-ABL, that has constitutive kinase activity, has permanent signaling, and is oncogenic. And now it took around 20 more years of research into the mechanisms and the biology of CLL for imatinib to pop up and completely change the therapeutic landscape in CML. As you can see here, the survival probability, and this is an old slide, but of imatinib as first-line therapy was, it was far better than the best treatment options at the time. So this really changed the landscape, and it served as a paradigm for targeted therapies, tailor-made therapies for particular cancers. Now, our own group, illuminated by these findings, tries in our own humble way to understand the mechanisms involved in tumor initiation, progression, metastasis, and resistance to therapy by focusing mostly on acute lymphoblastic leukemia. But not only, we also have research lines in lung cancer and brain cancers, but I'll be talking about leukemia essentially today. And what we want to do is to identify or to devise new insights into cancer biology, identify new targets for therapeutic intervention in doing so, and also devise new therapies. And I'll briefly allude to one of the strategies that we're following at the end of the talk. Now, acute lymphoblastic leukemia, for those who don't know, it's an aggressive hematological cancer. It's the most frequent childhood malignancy. It represents 1/4 of all pediatric cancers and 80% of all childhood leukemias. And it results from the clonal expansion of B and T cell precursors. So instead of one getting functional T and B cells in the periphery patrolling our organism to find infections and tumors and so on, we have a subversion of the system, and the B and T cell precursors actually become malignant cells. Now, we've been interested throughout the years not only in cell intrinsic alterations that are at the cause of the disease, but also on microenvironmental factors that may contribute to cancer development. And amongst these, we are interested in interleukin-7. IL-7 is a growth factor. It's a cytokine that is produced in the bone marrow, thymus, and other organs, including the brain and the skin. And IL-7, it's absolutely essential for normal lymphoid development. So IL-7 binds to the IL-7 receptor, which is expressed in developing B and T cells, and it's essential for their development. Now, IL-7 is also important in anti-tumoral immune responses by a number of different mechanisms. That said, similar to a very interesting novel written by this gentleman here, Robert Louis Stevenson, called The Strange Case of Dr. Jekyll and Mr. Hyde, IL-7 has a sort of a dual facet. So it has a good side, as I said. It has clinical potential in anti-tumoral therapies, but it also has this Mr. Hyde side to it, and it can contribute to cancer development. And why do we know this? Because we and others have shown that IL-7 binding to its receptor in leukemic cells can actually contribute to leukemia cell survival and proliferation in vitro, and in vivo, based on animal models that we generated and also on data directly collected from patients, we have shown that IL-7 can accelerate disease progression. Moreover, and importantly, we have showed that a subset of leukemia patients has IL-7 receptor gain-of-function mutations that make the receptor function constitutively and in an oncogenic fashion. What we didn't know until recently was whether IL-7, these mutations that we identified, were able to trigger the whole leukemogenic process. So they are obviously oncogenic, but can they be at the stem of the disease, so to speak? So to try and understand this, we generated a conditional mutant IL-7 receptor mouse in which the expression of the mutation in the IL-7 receptor is restricted to lymphoid cells. And the expression is absolutely normal. The only thing that we introduced there, it's the mutation. So the receptor is regulated physiologically, pretty much like what happens in an acute leukemia patient. And what we found was that all the mice that we generated had what we call the pre-leukemic phenotype. So there was an accumulation of these immature B cells in the peripheral blood of all the mice. And after a while, a fraction of these mice ended up having a huge expansion of these immature B cells in the peripheral blood. And eventually the mice died, as you can see here, with leukemia, with a very high penetrance, over 70%. And similar to what happens in patients with advanced disease, the leukemia spread from the bone marrow to different organs, such as kidney, lung, spleen, and brain. Okay? And importantly, the mice had a phenotype that resembles pretty much what happens in humans. So the leukemias were arrested at an immature B cell stage, so from the pro-B cell stage to the small pre-B cell stage. What we also saw was that at the pre-leukemic stage, as you can see here, so the more reddish, orangey dot squares mean higher induction of these genes, and these are all IL-7 receptor target genes. And you can see that in pre-leukemic cells, there is, as one would expect, because we have IL-7 receptor mutation, we have induction of IL-7 receptor mediated signaling. But quite strikingly, in leukemic cells, the IL-7 receptor mediated signaling really boosted. So there was association with very high levels of IL-7 receptor signaling and leukemia. And we confirmed this by looking at genes that are regulated by STAT5, which is a downstream effector of the IL-7 receptor, by looking at genes regulated by mTOR, which is another member of the IL-7 receptor signaling, and we confirmed this by gene set enrichment analysis, looking at transcriptomics and proteomics of the leukemias in the mouse. And importantly, we confirmed also with a good old-fashioned Western blot that S6 was highly phosphorylated in leukemia cells as compared to controls, and S6 is a target of mTOR. So this indicates that leukemia cells have high levels of activation of this pathway too. Now, because of this association between leukemia and high levels of IL-7 receptor-mediated signaling, what we speculated next was that if the signaling levels are really causal to the disease and are the reason why we have leukemia, then if we boost the signaling further, we should accelerate the disease. So to try and understand whether this was true, we crossed mice in homozygosity. So instead of having just one mutated allele, these mice now have two mutant alleles of the IL-7 receptor. And as you can see, there is an increase in the signaling, in IL-7 receptor-mediated signaling. And we confirmed this again by Western blot. And what we got was, fully fatal, very rapid leukemia development, indicating that indeed IL-7 receptor, high levels of IL-7 receptor signaling are causing the disease. Not only that, but this is important therapeutically, the cells rely on IL-7 receptor-mediated signaling, because if we block the signaling with different small molecule inhibitors of different members of the signaling pathway, we kill the leukemia cells. Now, you may be asking what happens in terms of T-cell leukemia development, and what we found out is that if we want to generate leukemia downstream from IL-7 receptor mutation in the mouse, we need to have high levels of signaling in committed T-cell progenitors. So if the expression of the mutant occurs earlier on the hematopoietic tree, we get BALL, not TLL. We need this to occur, the mutation to occur at committed T-cell progenitors. And we confirmed this in another study that has just came out of the oven. It was published yesterday in Leukemia, and which shows that mutant IL-7 receptor expressed in transgenic zebrafish leads to TALL that spreads to the whole body in roughly 50% of the zebrafish, and these leukemias have high levels of IL-7 receptor signaling, as I showed also for the BALLs. Importantly, the leukemias associate with decreased apoptosis as compared to controls. Okay. Now, an important issue here is that in addition to IL-7 receptor mutations, which occur only in a fraction of the patients, we have other patients that have very high levels of expression of the IL-7 receptor without necessarily having mutations. In some cases, they have gains. In some cases, we don't know the reason for the high levels of expression. But what we found and what we showed recently is that by combining two different animal models and data collected directly from patients, that high levels of IL-7 receptor, even if it's the wild-type receptor, can be oncogenic. And then we show that we can treat the TLL cells, we can target them by using a number of pharmacological inhibitors of IL-7 receptor-mediated signaling. I won't show you these results for the sake of time, but bottom line, around 70 to 80% of TLL patients either express clearly the IL-7 receptor or have IL-7 receptor gain-of-function mutations. A smaller fraction of BALL patients fall into the same category, and so they can potentially benefit from therapies that target IL-7 receptor-mediated downstream signaling, okay? And we showed evidence of this. You can check the papers both in vitro and in vivo. Now, what we are also devising currently are two complementary strategies, one that is microRNA based, and I'm happy to discuss with those interested, and we have an ongoing project dedicated to that, but directly related to the IL-7 receptor story that I have just told you. We have devised by phage display a fully human anti-IL-7 receptor antibody that we believe can be a new tool to target IL-7 receptor expressing leukemias, and that we want to try to take to the clinic, and that's what we are ongoing also exploring in the lab. So overall, and I hope I kept to the time, what I hope I showed you is that on one side of the scale, so to speak, we have suboptimal IL-7 receptor signaling that we know for many years that leads to immunodeficiency and severe combined immunodeficiency. But on the other hand of the spectrum, if we have excessive IL-7 receptor-mediated signaling because of IL-7 receptor gain-of-function mutations or because of high IL-7 receptor expression, potentially also because of autocrine IL-7 producing loops that we and others have described, we can have increased IL-7 receptor signaling and leukemia develop. And so we believe that we can, for those patients that are reliant on IL-7 receptor signaling, we can use anti-IL-7 receptor antibodies, perhaps in combination, of course, with the conventional chemotherapy, but also with targeted therapies aiming at inhibiting IL-7 receptor downstream signaling. So the last and most important slide, all the people that from my lab that participated in these and other works that we have in the lab, collaborators, the funding, and I thank you all for listening.
Thank you, João. Thank you so much for your presentation. I'm always amazed how we have advanced in research and knowledge in medical matters. I have to say that I understood very little of your presentation. This is not my area. But one thing I could understand from all your presentations is that we need, in fact, different levels of research, from very basic research on understanding mechanisms down to treatment and to screening and to precision screening, down then to devise people-related treatments. So that in fact is what we all know is that in research we need everything from all the TRLs, from the first one, from fundamental research to really the innovation step. So thank you all, thank you Rebecca also away for your presentations.
Can I say one word?
Of course we have...
I think the next diplomats is going to be Cristiano Ronaldo and Mo Salah.
I think we have 2 or 3 minutes left, so I would like to ask the audience if you have some comments to do. And I'm looking at Mohammed Al-Shinawi. He is also working in this area. Would you like to comment something?
First of all, thank you so much. Let me introduce myself. I'm Mohammed Shinawi. I'm a professor of surgery and oncosurgery in Ain Shams University, and I'm the advisor to the Minister of Higher Education and acting president of Galala University. Before I give the comment in few seconds, I would like first to thank Portugal for this honor for having Egypt as the guest country, and we really benefit a lot. And I hope that the cooperation between our two countries will get a lot more fruitful in many aspects. Let me just comment in the first presentation when the presenter, and I hope she's hearing me, when you're talking about screening of patients in breast cancer less than 50 years, actually in Egypt, as Dr. Shireen was mentioning, the 100 million health, we in Egypt, we have the average age of breast cancer is around 45. So actually in Egypt, we start the screening at the age of 40. And this is one of the things that I hope that we can start discussing together and how we see the effect. Because why in Egypt breast cancer starts in average of 45, while most of the Western countries and here in Portugal, we're talking about the age of 55. So this is one of the areas I think we can have cooperation, not only in breast cancer, but actually breast cancer, colorectal cancer. In our studies, we did 100 million, the 100 million initiative, we screened more than 3 million Egyptian females, and we had very good results in this regards, and I think we can cooperate in this incident. And I think we have to compare between the Egyptians, or I would say the Middle East, because this is something related to the Middle East, and the third and fourth generations who immigrated to Europe and especially to Portugal. And this is in colorectal and in breast cancer. When she talked about biobanking, biobanking is one of the very essential things that I think we have to consider and make it like an international project, because having and sharing data, which is everything is based on, is very crucial. Talking about what Dr. Shireen was talking about hepatitis and the cure, I think this is very crucial, especially when we talk about not only hepatitis, but the consequence of hepatitis, which is hepatocellular carcinoma. Also, this have to be considered. So this is one of the prevention. Talking about your presentation, Joao, which is very interesting, because I'm a surgeon, but I'm working with a lot of scientists. And when you go to the immunology, I will tell you, and I will share with you, allow me, Elena, that I will send you, we have similar results as regard the immunity and relation to breast cancer, and how the macrophages are playing a big role in the metastasis of breast cancer cells. And at the same time, we are correlating this with some of the viruses, and allow me to share with you these results that we did in Egypt in cooperation with different institutes that I hope, like NYU, New York University, Memorial, MD Anderson, things in the United States, and some of Germany. But of course, it will be a great pleasure and honor to share it with our Portuguese scientists. In the end, we had a perfect and really a very, I would say, visit for all the Egyptian delegation. And I think we have a lot to build on this visit and a lot to come. And thank you so much for the hospitality.
Thank you so much, Mohammed, for your presentation. And in fact, you highlighted one of the successes of these meetings, which is to put together people from different countries, and in case to have the advantage of having a guest country and exchanging ideas between us. So, and I hope, we all hope that fruitful cooperations will arise from this meeting. Thank you so much. I think we are in time for the closing session, so I thank you, all of you. Thanks a lot.
Thank you.
We are finalizing our Ciência 2022, Science 2022. Before calling to the floor those important people who will close the session, I have to say thanks. Thanks to a lot of people. Thanks, of course, to the participants of the meeting, those who spoke, those who made posters, those who were present here and those who were present at home or elsewhere on a remote basis. Thank you all. I thank also, of course, the organizers. This is, as you can imagine, this 3-day session is quite a nightmare of logistics, as you can imagine. So I thank all the people that worked to make this possible. Or the magic. Well, of course, the people from FCT, they were incredible, amazing. All the staff of FCT worked a lot, directly or indirectly, because since we were here, they had to do all the job at the office. Also, Ciência Viva, they were also amazing. We all see these young people around with the green T-shirts. They are great. As well as the cabinet of the minister, they also helped a lot. So everyone was really helping, and this is really also a demonstration that we can achieve great things, but only with people. And we have to motivate people. So thanks to all of them. And now, to start the closing of the session, I will call to the floor our minister, our new Minister of Science, Technology and Higher Education, Professor Elvira Fortunato. Please, Elvira.
Excelentíssimo Sr. Embaixador da República Árabe do Egito, em Portugal, Val El Nagar, Excelentíssima Presidente da Fundação para a Ciência e Tecnologia, a professora Helena Pereira, Excelentíssimas Comissárias do Encontro Ciência 2022, professora Teresa Ferreira e professora Teresa Pinto Correia, caros participantes, caros convidados, muito boa tarde. Em primeiro lugar, quero agradecer à delegação do Egito a excelente colaboração e a importância que as várias intervenções tiveram. Penso que o trabalho que já iniciámos há uns anos ficará muito mais forte depois desta jornada e destes 3 dias em conjunto. E esperamos que esta colaboração seja ainda maior nos próximos anos. Foi sem dúvida um prazer ouvir e ver centenas de investigadores ao longo destes 3 dias em dezenas de sessões que nos possibilitaram o diálogo, que nos aguçaram a curiosidade, mas principalmente o sentido de urgência de concretizar. E temos muito trabalho pela frente. Aliás, na ciência não há desemprego, ainda bem. A edição deste ano do Encontro de Ciência esteve centrada, como já foi mencionado, nas 5 missões definidas pela Comissão Europeia. Estamos perante um desafio tão ambicioso quanto necessário para responder aos problemas que se colocam atualmente aos cidadãos na área do cancro, das alterações climáticas, das cidades, dos solos, dos alimentos e dos oceanos. Para alcançar as soluções necessárias, é fundamental reforçar a articulação entre a investigação e a inovação de uma forma multidisciplinar e com o envolvimento das pessoas, das regiões e promover a crescente internacionalização das nossas instituições científicas e académicas. Queremos, por isso, duplicar a participação portuguesa no próximo atual quadro europeu de investigação e inovação, em particular o Horizonte Europa, porque a presença e intervenção da comunidade científica em projetos financiados pela União Europeia e projetos internacionais é estratégica para o processo de convergência de Portugal com os países avançados. Temos de ser mais competitivos em termos europeus e de diversificar as fontes de financiamento. É igualmente crucial reforçar a cooperação europeia nos 4 pilares do Programa Horizonte Europa, com ênfase na participação nacional, quer no European Research Council, em projetos de investigação colaborativa, mas também nas parcerias institucionais e nas 5 missões do Horizonte Europa, no European Innovation Council, assim como no programa Teaming. Este esforço de internacionalização deve ainda incluir a inserção das instituições em redes europeias, fomentando a mobilidade de estudantes, docentes e investigadores, a sua integração na iniciativa Universidades Europeias, através da constituição de alianças transnacionais e a promoção da cooperação internacional do ensino superior politécnico, estimulando a inserção também dos politécnicos em redes internacionais no mesmo âmbito. Sabemos que a convergência com o espaço europeu passa também por adotar práticas idênticas às que são seguidas em contexto internacional. Nesse sentido, continuaremos a promover a simplificação e a desburocratização do sistema de ensino superior, ciência e tecnologia, flexibilizando as regras de execução financeira e de contratação pública. Esta é uma das medidas mais importantes a que nos propomos trabalhar. Queremos um simplex para a ciência, assim como trabalhar numa base de confiança. O programa da área governativa da ciência, tecnologia e ensino superior foi elaborado a pensar nas pessoas, porque a ciência precisa de pessoas. A comunidade científica e académica precisa de estabilidade e previsibilidade. Precisa de um espaço de investigação inclusivo, justo e que permita o desenvolvimento pleno da ciência e da inovação. Sei bem que os nossos investigadores precisam de ver que o conhecimento por eles produzido é valorizado do ponto de vista social e económico. A ciência, como já foi mencionado aqui, faz com pessoas e para pessoas. Obrigada mais uma vez pela vossa presença e pelas vossas contribuições. Viva a ciência e espero vê-los no próximo Ciência 2023, para o ano, com um novo formato e também numa outra cidade de Portugal. Muito boa tarde. And now it is my great pleasure to ask to the floor the Excellency the Ambassador of Egypt, Val El Nagar.
Let me first thank you very much for having this opportunity to be here. Your Excellency, Professor Frantura, the Portuguese Minister of Science, Technology and Higher Education, President of the FCT, Science Viva, the scientific commissioners, and your team in the Ministry, of course. Distinguished participants, ladies and gentlemen. First of all, I would like to convey the thanks of His Excellency, Professor Khaled Abdelghaffar, Egyptian Minister of Higher Education and Scientific Research, the Portuguese government, and Her Excellency, the Portuguese Minister of Science, Technology and Higher Education. We thank you very much for hosting Egypt as the guest for the science fair. The Science 22 was a very good opportunity for both countries to get together, to build a bridge of knowledge, science, and future prospective cooperation. We would like also to express our gratitude to Ms. Helena, the President of FCT, and her team and their devotion and efforts in organizing and facilitating all issues related to the participation of the Egyptian delegation in the conference, which has successfully concluded its session today. The session today reflected very much what we both wanted in collaboration, the exchange of knowledge, of future partnership. And we would like also to congratulate FCT for the 25th anniversary. Ladies and gentlemen, this year, Egypt has participated in the conference with a wide range of its most reputed scientists and calibers who have engaged in several sessions and thematic workshops in different fields of science and research, meeting their Portuguese counterparts, exchanging the scientific knowledge between both sides, fostering the human interaction, and consolidating the academic ties between both countries. We took this advantage, and our minister took this advantage that we did on the sideline of the conference bilateral consultations on how to enhance our bilateral meetings and general relation to come to a mutual interest in the fields of higher education, scientific research, and health, in order to reach a mutual base of cooperation for the benefit of our two beloved countries. Ladies and gentlemen, hastening the bilateral scientific relations between Egypt and Portugal is a cornerstone for the development of the relation between the two countries. Given the importance of this field in the world after the pandemic, which will be driven by not only green, but green, blue, and digital transitions. Finally, I would like to assure Your Excellency that it is the honor of Egypt to receive Portugal as the guest country of the upcoming 8th Cairo International Exhibition of Innovation, which will be held in Cairo, December 2022, under the auspices of His Excellency President Abdel Fattah el-Sisi, the President of the Arab Republic of Egypt. Allow me once again to thank you for having Egypt as your guest. Thank you very much.
Para encerrar a sessão, uma mensagem em vídeo do Presidente da República, Marcelo Rebelo de Sousa.
Caríssimas e caríssimos organizadores e participantes do Ciência 2022 ou 2022. Infelizmente não posso estar presente na vossa iniciativa por me encontrar em viagem por Timor-Leste, celebrando 20 anos da independência e a tomada de posse do presidente recém-eleito. Mas não quero, apesar disto, deixar de vos dar uma calorosa e simbólica manifestação de apreço, de reconhecimento e de solidariedade. É sempre um gosto enorme verificar que, ano após ano, o Ciência, Encontro Anual da Ciência, Tecnologia e Inovação em Portugal, se reinventa, oferecendo-nos um programa que demonstra o melhor que se faz no nosso país e no mundo. Entre tantos tópicos que foram debatidos no Ciência 2022, salientaria as questões climáticas, a ecologia, a gestão de recursos naturais, os ecossistemas, as cidades sustentáveis, os oceanos, claro, este ano da Conferência das Nações Unidas, dentro de semanas, pois para todos eles a discussão é urgente relativamente ao futuro sustentável do planeta. Os meus parabéns às comissárias do Ciência 2022, que trouxeram estas questões prementes para a mesa da discussão, a senhora professora doutora Teresa Pinto Correia, do Laboratório Associado Change e Universidade de Évora, e a senhora professora doutora Teresa Ferreira, do Laboratório Associado Terra e do Instituto Superior de Agronomia. O encontro deste ano foi especial, tendo duas celebrações, quase em simultâneo, para não dizer em simultâneo. No dia 16 de maio, celebramos o Dia Nacional dos Cientistas. E temos tanto a agradecer aos nossos cientistas, cá dentro e lá fora. E em rede, presentes em toda a parte, por todo o mundo. Porque à sua maneira isso permite-lhes estarem presentes em todos os momentos, nos bons e nos maus. A trabalhar incansavelmente para encontrar soluções criativas para os mais variados desafios do desenvolvimento sustentável. E houve momentos maus, a pandemia, 2 anos muito, muito maus. E não é bom um momento da ressaca da guerra em efeitos económicos, financeiros e sociais. Agora, há uma coisa que é constante, o nível dos cientistas portugueses. São, de facto, dos melhores a nível internacional. Mas, precisamente por isso, vamos repetir uma ideia que já conhecem, é crucial e é urgente dar-lhes condições para que possam continuar a sonhar, a inovar e a trabalhar. Mas, ao mesmo tempo, celebramos os 25 anos da Fundação para a Ciência e Tecnologia, a Agência Nacional da Avaliação e Financiamento da Atividade Científica, responsável pela construção do conhecimento sobre a ciência e tecnologia em Portugal, e com a qual eu já colaborei nos meus tempos académicos, mas que já são relativamente antigos. Ficam aqui os votos para que possa crescer e consolidar-se cada vez mais. Um cumprimento muito especial para o Egito, o país convidado deste ano, com uma história riquíssima. O Egito contribuiu verdadeiramente para o estudo e conhecimento da matemática, da medicina, da astronomia, da agricultura, sendo pioneiro em muitas destas áreas. O seu impressionante legado sobreviveu até aos nossos dias. Quero terminar formulando um desejo muito simples, mas muito fundo. Que Portugal construa o seu futuro com ciência e para a ciência. Lembrando sempre que os cientistas são aqueles heróis discretos que lutam sem parar contra os grandes desafios que o nosso planeta, a nossa vida, a nossa sociedade, que as pessoas de carne e osso enfrentam todos os dias, todos os anos, ao longo dos séculos e milénios.
Damos por terminado o Encontro Ciência 2022. A edição deste ano contou com mais de 2.700 participantes aqui no Centro de Congressos de Lisboa e quase 4.300 participantes online em 100 sessões plenárias, 66 temáticas, com 400 oradores, 225 comunicações e 52 demonstrações e um conjunto de pósteres de jovens investigadores. Esperamos por todos no próximo ano para o Encontro Ciência 2023. Até breve.